Okay guys, so today we're going to start solving exponential equations with the same base, and if they're not the same, we're going to make them the same. And then when you come back from break, we're going to look at when you cannot make them the same, and we're going to start those log functions. So let's take a look at example 1. Anytime that you have this rule right here goes a lot with these problems, where this means the b, okay, is the base. If it's the same base, then the exponents equal each other. So for instance, here it's the same base, 2 to the x plus 6 equals 2 to the 5th. So you can cross off the bases and make the exponents equal each other. So x plus 6 equals 5, subtract the 6, so x equals -1. And that's all there is to it. Now that's a simpler one. Let's take a look at example 2. Now you can see here there are 3 bases. Now they're all 4s, so you can cross them off, but when you set up the exponents to equal, okay, from the left to the right side, everyone makes this mistake and does 3 times 2x minus 6. Over here, put a little star as a reminder. When you multiply expressions like x squared times x to the 3rd, you add the exponents. So that would make x to the 5th. Here, we're multiplying expressions, okay? Let me turn this lamp on. We're multiplying expressions with exponents, so you do not multiply the exponents, you add them. So when we rewrite the equation, it's 3 plus 2x minus 6 equals x plus 9. And then you have a multi-step equation, but the biggest mistake people do is they try to do distributive property and multiply there. The rule is, if you're multiplying exponential expressions, you add the exponents. Keep that in mind. So let's solve this, combine like terms. Then I'll bring the variables over. And then add the 3. So x equals 12. Okay? Now let's look at example 3. If you notice, actually, example 3, 4, and 5, they don't have a common base already. That's where you need to know your powers, okay? Some of the basic ones. Meaning here, we can change them to a lower number. We can rewrite 9. Instead of writing it as 9, let's write it as 3 squared. And then for 27, instead of writing it as 27, let's make it a same base of 3. So 3 to the 3rd. Now, here's how it works with that 2x minus 5. You just leave it up here. Make sure you put it in parentheses. It's still the exponent. So make sure when you write that, you still leave it up there as the exponent, but put it in parentheses. Because this is where you cross off the common base, and you're left with the equation 2 parentheses 2x minus 5 equals 3. This is where you do distributive property now. So we solve the equation, 4x minus 10 equals 3. So I will add the 10. 4x equals 13, and then divide by 4. And you could leave it like that or give a decimal. It's no big deal. I'll just leave it as 13 over 4. But notice your goal is to solve these. No calculator either. Okay, you're going to be practicing without a calculator, not putting in y1 and y2 anymore, by hand, okay, make them a common base. So, for instance here, let's look at example 4. Well, we cannot take 125 and change it. 25 squared is 625, so there's no way to change this into that base. So, let's go lower than both these numbers. Always go lower. Let's change this to an exponent with 5. Okay, so 5 is the base. So 5 squared makes 25. So then in parentheses, I'm going to leave the exponent that was already there from before. If I change this to a base of 5, which I did, then I'm going to change this to a base of 5 and make it 5 to the third. Then again, the exponent doesn't go anywhere. Leave it as 3x plus 4. Once you get that common base, cross it off and take the two exponents and set them equal to each other. And then from there, do distributive property. And then make sure you remember how to solve the equation correctly. So I'm going to bring the variables to one side and the numbers to the other. And there's my answer. So the hardest part is make it a common base, okay? Make it a common base. Now, there's a couple ways you could go about doing it for number 5. You could make them a base of 2, okay, all of them a base of 2, or you could work backwards and do the opposite of multiplying by 2 is dividing by 2. You could do that, and then that leaves you with 4 to the 3x minus 1 equals 8. But then even at this point, I mean, you still need to make a common base. There's no way to solve for this exponent. You're not dividing by 4 or anything. It's an exponent. So we could change, well, 4 squared 16, so we can't change this to a 4. Let's change both of these into 2. So 2 squared will replace the 4, because that's equivalent. The exponent stays in the exponent. Just put the parentheses there. And 2 to the third is the 8. And now that we have a common base, I can cross it off, and I can leave it as 2 times 3x minus 1 equals 3. Do distributive property, and solve. And then divide by 6, and x equals 5, 6. So this is your goal today, guys, to be successful and try, again, you want to make a common base if they're not already a common base to solve these exponential equations. On the back of the paper, there are 12 problems. Do not use your calculator. I want you to practice it, okay? And then you'll get the answers for each of them. So that way you'll get a chance to check. This is what the first thing we're going to start with when you come back from break is practicing these and using logs in addition to it. So make sure you have this down.